Seconds in wave brings sensations, when hours in traffic lines brings nothing but pollution. Surfing shows us that time means nothing. Learning surf physics intensifies our seconds in waves. Shape of wave dynamics explore this surf space-time. We have selected for this tutorial a wave located in France, called Parlementia, in Guéthary, Basque Coast. Facing northwest, and it's a rock wave. We will therefore see this wave according to its bathymetry, and we will use its bathymetry in the surf zone, oriented in the direction of the swell to generate a wave in the waveroom. So here we see the northwest swell bathymetry. We will turn it over and orient it in the direction of the swell. And there, we therefore have a bathymetry oriented in the direction of the swell. We will therefore carefully observe the surf zone and take a reading of the altitudes in this surf zone, which are around 350 meters here. We are going to simplify this map starting from a depth of 20 meters. And here, we are going to add zones of 5, 10 and 15 meters, to have a simplified map of our global bathymetry. So we are now going to enter these altitudes in a grid on our waveroom. So, we are going to go to the waveroom tab and activate the settings options for the bottom, the bathymetry. And we are going to resize the grid so that it corresponds to our grid of bathymetry. We have a width of surf spaces that is about 350 meters here. So we are not going to touch the number of points but simply the sizes of the columns and rows to enlarge, stretch our area. The optimum number of points is around 20,000 points. Going for more points is a bit complicated, it can crash your graphics card or your computer. A reasonable value is 20,000 points. But you can go anyway if your computer is capable of it. In the gray area, we can choose the size of our grid. We see, at the bottom here, the dimensions of 201 meters by 70 meters. We would like to have a surface that is 350 meters wide, and let's say 400 meters long. So we're going to position ourselves in the direction of the swell, so the ocean towards us, the beach in front. That's how it is, to have a somewhat clean. And we are therefore going to resize. We need 350 meters here in width, so we will modify the width of the columns, and we will change them to 1 meter. And we see that we go to 200, we're going to put 2 meters. 3 meters here, 300.5, 335. And we have a size of 370 meters in width. We are also going to modify the width of the row. To obtain a size of approximately 400 meters, we are going to put a 2, to have approximately 400 meters. We're going to reduce 3.6, 363 a bit here. Here we have a grid size that has been resized to 402 meters deep by 360 meters wide. We select bathymetry grid and we rebuild the grid. We are going to select all grid. And we are going to pass all selection level to 0. We have a plateau at 0 depth. We have our greatest depth, which is 20 meters. So we will go down the whole plateau to 20 meters. So we select vertical here and with the cursor. So we have the whole grid selected. And with the cursor, we are going to go down to 20 meters. So, a little trick to see the depth of a selected point displayed, you have to select the area here above. Display of the parameters therefore displayed. You will therefore see the parameters displayed in depth. So we push the cursor down to 20 meters. 181990. When the cursor reaches the end, at the end of its travel, we release it. It returns to the middle. We can continue the descent. Here is 20 meters. Now we are going zone by zone to raise to the different altitudes of the bathymetry. So in this project, I'm going to keep it simple. I will leave it to the specialists of Parliamentary to make a project much more precise than this one, so that it responds better to the characteristic of this wave. So a little trick is that if we select a point, and check, and select another point, it pulls us an area of selection. It makes a pretty fast section. So here is click in a place of the grid, control, and click in another place, it draws a square between the two selected points. So here, this zone there, I'm going to put it at 20 meters. I'm going to reduce it a little bit, I'm going to put it at 15 meters. I'm going to reduce it a little bit. Here it seems here the zone which is mainly at 15 meters. I actually pretty much average the area, and figure that area to 15. So I'm going to do a walk to 15 and then refine. So I select, I am at 20 meters, and with the cursor positioned on vertical, I will go up the area up to 15 meters. I am now taking the 10-meter area, so I select an area that is a bit far away, and I will do another step, at 10 meters height. So I always take my lever here and go back up 10 meters. So here I have mainly 3 steps, so 20 meters, 15 meters and 10 meters. We still have to close the 5-meter step. So I follow the meter right there. I will make it about the same size. And I go up to 5 meters, 10 meters, 5 meters. And now my last step, I make it 2 meters. So I select and I go up to 2 meters. Here. So I made a staircase that represents the main depths. Now I will refine my description. So I'm going to use copy-paste for that. And I'm going to copy small areas, and paste them back on the right, on the left. For example, here, we are at 20 meters, here we have the zone at 15 meters, we see that we have a zone at 10 meters which is embedded here. So I take the area of Ctrl plus C equals copy, from this area there, and I'm going to paste it here. To have an area of 10 meters approximately here that stands out, it's my little pad. So this little pad is surrounded by a 15-meter zone. Okay, I'm going to advance a small area of 10 meters here. I advance a little bit, so I make it quite simple. I'm not necessarily trying to do exactly, I just want to reproduce a similar area of 10 meters. In the other end, over there, I have a smaller zone of 10 meters, which goes a little to the side, like an upwelling. So here is a very simplified, very approximate bathymetry. Maybe here, I can make my little comeback from 20 meters. A little incursion from 20 meters, there you go. I have another one here. It is an incursion of 20 meters. Here there are 15 meters, which goes around. There I have roughly my area, so very schematically modeled. Now I'm going to smooth the whole thing so that the areas are eroded in a more natural way. So I select the whole grid by checking here. And I'm going to do smooth 10. And my bathymetry will erode. I'm going to erode it again, here it is. So I uncheck my global selection. And now, I created my bathymetry, which looks a bit like what I found on the map. So that was a first draft, and we will now see what happens when we model it. For that, just to do rebuild wave, and we will test our wave on this new bathymetry. So here is my modeled wave. We will deactivate the swell, to see only the surfable zone, and we will watch how another wave evolves. So there I'm going to put myself in slow speed. We can see the peak. We would suspect it on the zone, which goes up here to 10 meters. So a nice climb from 20 meters to 10 meters, we can see that it is somersaulting and accelerating a little, to see what's going on. So no surprise on the peak. Now, what you have to see is how it unfolds on the rest of the bathymetry. A second peak forms here, it's one that will close here. We have a somersault on this echo there. So for those who know, the wave does not close that much here. So this altitude must be a bit high. So you see, we can like that go and seek to sculpt our wave. So I speed it up here to see what happens. Then we see that there after a few seconds the wave stops, and is over. In fact, the modeling time is defined by the detection of the last peak. So, to increase the modeling time on the surf space, we go to the surf space settings tab, and we will increase the duration after the last detected peak. And we're going to go to 100 here. And we're going to rebuild the surf space. So that's going to last 100 cycles. After the detection of the last peak, it would allow us to have a wave that is followed a little longer. So we rebuild the surf space. I deselect the swell, and we will now see our surf space, which is modeled in a longer way. So there, here, we have a surge because of this bump here. So we would have to see in reality if it is really as deep as that. What are the differences between our reading and the reality? Here, I simply propose to obtain a wave that corresponds more to what we know than the amateurs of this wave know. So we're going to lower the altitude a little bit here. I'm going to go back to my wave, and there, I'm going to the vertical zone. Going down this zone there in order to eliminate this abnormal peak. So I made a sort of rectangle. Basically, I'm going to select an area all around and do the smoothing so that this area is restored to more consistent values. Here, our square is a little big, but I leave it like that. So I go back to swell settings, and restart the construction of the wave. So here we see how we model our wave based on our survey. And we'll try to get our wave. Here is our rebuilt wave. We are going to remove the swell and go back to the start. Slow down slightly. We'll see what happens. So the surge here. We are going to accelerate a little by going to real speed. That we see here that it breaks, it is because of the defect. Here, we are going to delete. Okay, we're just going to break this bump here, which is normal too. So I make a selection of the area here that interests me. I'm going to have this area copied and erased where we have an entrance, normally the port channel. I'm going to soften, smooth the area. You see how our wave is sculpted a little to give it the shape we want. When we worked for a while on the bathymetry, it's good to save, so I'll do save bathymetry. I choose a name. In this case, it will be Parliamentarian Uist. I'm going to put 2 because I've already done some recording tests. And so there, in our library, we recorded this bathymetry. And we will only have to drag it into a wave if we want to test it for one project or another. So here is our bathymetry modeled here. What we can do is orient the bathymetry. There it was northwest. We are going to try to put it more west. We are going to make a western model. So what we do? We select the whole grid and we're going to spin. So if the swell comes more from the west, here it is a northwest swell. If the swell comes more from the west, so our whole set will relatively rotate like this. So I select in rotation. I select the entire background grid, and I rotate it in this direction. So much for directing it to the west. So this bathymetry, I call it west-northwest. We thus see that we can, once we have done a bathymetry for a given spot, simulate several arrivals from several swell orientations. So I select it and I do save bathymetry, and I will call it west-northwest. So I could test it right away. There. Saved so I can test it. So here the period is a little weak for this type of place. So we are also working a little on the period. So there you go, we went up a wave to the west-northwest. We're gonna hide the swell back up to 0. Slow down a bit and see what happens. So all tumble on our dome here. So, for once the wave is built. To select the wave, we can get out of the setting option. Like that, when we select the wave, we refocus on it. We'll watch the takeoff on that. So there we have a part. We see that there is an area that will accelerate a little bit. So here it is. In fact, the shape of a wave can be worked on very precisely by modifying the different ground parameters, and trying to get as close as possible to the existing one. And try to achieve a wave, as we really know it. It's work, it's not easy either, but now, you have all the levers to be able to achieve the wave you want. We will now see how the period parameter works. Here we have a fairly low period. We will lower the length factor. We will increase it to 600, and that should increase the period. So we have reconstructed a wave with a period of 10. We will erase the swell and return to the beginning. And we launch the simulation. We're at the point of takeoff. So there, in the wave room, we didn't put on a surfboard. It's just a wave sighting. We uncheck the dynamic option, and we just observe the wave. Let's say we're happy with our bathymetry. We have seen how to rotate it to simulate a swell from east to west, north, northwest by rotating it, recording. Now we can also simulate a variation in tidal altitude. That is quite important, and this is what happens very frequently. Bathymetry data is usually given for low tide. So if we had 10 meters here we are in a low tide option. We're going to raise the tide by a meter. We're going to bring all this up a meter. Simply, we have a slider here. Variation size. So I'm going to select a point from the bathymetry. I will watch here, it is marked depth 10 meters. I'm going to lower all this a meter, it's as if the tide had risen a meter. There I made a variation of 1 meter. It's as if the tide had risen by 1 meter. We made a variation of 2 meters, so it's a simulation of the tide in relation to the starting point of 2 additional meters. I'm going to record it right away so I don't confuse. I'll call it. So here it was west, northwest. And I say 2 meters, to remember. And I will therefore relaunch. The same conditions of period and amplitude on this new bathymetry lowered by 2 meters. To simulate an increase in tide. So we see that we can really model the surf spot in all the conditions we are interested in. If you are happy with a wave, you can name it and put it on the surf community and share it. We erase the swell. We are only interested in the surf space, and we go to the beginning. We will go in slow motion, and we'll see what happens. So there, we have raised the tide by 2 meters. And we are going at slow speed. We observe the takeoff. It's a little less bold, it's a little less precise at the level of the takeoff. So here is our modeled wave with tide 2 meters more. So that's all for this small tutorial, which consisted in showing how to model a given wave with the wave room of Shaperwave Dynamics.